Hello everyone! This video by NOI.ph will help introduce newcomers to competitive programming. In this video, we will go over the basic idea and format of the NOI.ph contest. The core ideas of the format are basically the same across almost all competitions of this type, and are fairly straightforward. We will dissect two sample problems which are available in the public NOI.ph group on Codeforces, link in the description, so that you can follow along with us. We've also divided this video into chapters. Take a look at the scroll bar for your easy reference. Let's begin. So first of all, what is NOI.ph? The National Olympiad in Informatics, Philippines, is an informatics Olympiad where contestants solve algorithmic tasks by writing correct and efficient programs. Let's try to break that down. National means everyone in the Philippines can join this contest. Informatics is the science of studying efficient methods for storing, processing, and retrieving data. An Olympiad is a major contest in a particular game, sport, or scientific subject. Like many scientific Olympiads, the contestant, you, will be given a number of tasks to solve within a limited amount of time. What do the tasks of informatics Olympiads look like? Let's compare it with a typical task in a math Olympiad. Given this rectangle with a length of 3 and a width of 4, what is its area? Your expected output would be a number, the value that answers this question. In this case, after you do some computations, you would find that the area is 12. Now, if it were an informatics task, it would look a bit more like this. Write a program that, given the length and width of a rectangle, here as L and W, is able to find that rectangle's area. What you submit is not the answer to the problem for any particular set of values, but rather a program that is capable of solving the general problem. The judge will then check the correctness of your program by running it against several different test cases. Your program will be fed some input, here, the values of L and W, and the judge will check that it is producing the correct output, here, the area of the rectangle. If your program produces the expected output for all test cases, it will be accepted. If it's wrong on any of them, you will get a wrong answer verdict. Let's see how this would look like on the contest platform itself. I've already joined the group NOI.ph, so I'll go here and click on the contest NOI.ph Abacoda tutorial. Let's look at rectangle. That's the problem we discussed earlier. Alright, so here we can see, here's the structure of a typical task on Codeforces. The exact layout will differ depending on the platform, but the same information should always be available. First, here we have the problem title, and underneath it a time limit and a memory limit. Remember that your program doesn't just have to be correct, but also efficient. If your program takes too much time or consumes too much memory on any one test case, then it will be flagged as incorrect, with a time limit exceeded or memory limit exceeded verdict. Also, there is a runtime error verdict for if your program crashes and just doesn't finish executing. The memory limit is often large enough that we don't have to worry about it too much most of the time. We'll talk more about how to handle the time limit later. Right, next, we have the problem statement itself. Sometimes it will come with a story or some other scenario. Other times, you'll just have a clean, formal statement like in this one. All the same, this part will tell you what your program should do, i.e. what problem it should be able to solve, right? Like here, your program should be able to find the area of a rectangle. That's the thing it should be able to do. Next, we have the input. Your program will read the input values from standard input, which just means use input in Python, cin in C++, etc. Standard. This section will tell you how the input is going to be formatted, which is important so that your program will know how to read it. For example, here, The length and the width are given each on their own line. Sometimes lumped in with the input section are the constraints. Basically, these are promises from the test authors that the input in each test case will satisfy some restrictions. You don't, I repeat, I want to emphasize this, you don't need to check that these are being satisfied with an if statement or something. The only input your program will be tested on will always follow the given format and will always satisfy the given constraints. For instance, we see here that L and W are positive integers, at least 1 and at most 100. So we don't have to consider our program's behavior for weird edge cases like, oh, what should the area be if the side lengths are 0? Or what if the side lengths are negative? The constraints are a promise from the problem setter that such cases won't be tested, so don't worry about it. These constraints are especially important when we want to check if our program is efficient enough to fit within the time limit. Again, we'll discuss that in more detail later. Next section is the output. It tells us how it wants the output to be formatted. In this case, it just wants us to print out an integer in a single line. But more involved problems could have more complicated outputs. Your program should output at a standard output, which again is just print in Python, cout in C++, etc. Keep in mind that you need to follow this format exactly, because the judge that I mentioned earlier, judges don't test the solutions manually. The judge is a computer program too. So all testing is done automatically. So if you don't follow the output format, the judge won't be able to understand your answer, and your answer will be flagged as incorrect. We'll show some concrete examples of this in a bit. Finally, all problems come with sample input and output, which exist as a guide to help make sure that you properly understand the problem. For example, we see here that if the input is 3 and 4, then your program is expected to output 12, which makes sense because we can manually compute that 12 is in fact going to be the area of such a rectangle. Note that we can also use this to verify that we understand the input format correctly. See, 3 and 4 are given each on their own line. We can see that. Also, if the author feels it is necessary, they may include an explanation for the sample test cases. There's none here because we know how to get the area of rectangles. Remember though that these are only examples. Your program will still be tested against several hidden test cases. It's possible that your program will solve the samples correctly, but fail on some hidden test case. In a live contest, you won't be told what test case your program was incorrect on, which can be frustrating, but debugging these hidden test cases is part of the competition. Now, okay, let's try submitting to this task. I'm going to use an online Python notebook, Google Colab, to make this easier. Of course, you can test locally or use something other than Python, but I'm going to use Python to make this short and simple. This Google Notebook actually contains the same contents as this video, practically, but in a nice interactive format. You can go at it at your own pace. We'll leave a link to this in the description, but actually, just for now, want a space to code. So let's solve the rectangle problem. First, we read the value of the first line, which should contain the value of L. So I'll read that like that. And then we'll read the value in the second line, W equals input. And we know that the area for rectangle is equal to the length multiplied by the width. So after reading those into input, from the input I mean, we'll print out L times W. Alright, this looks good. Let's submit it on Codeforces. You can either submit here, you can choose a file and upload it, or since I came from a notebook, I'm going to click Submit Code. I'm going to select Python 3 here and paste it. Submit it and we'll see. Runtime error on test 1. Why did we get a runtime error? So you'll notice I made a mistake, which is that I didn't test before submitting. Please test before you submit. Okay, well, okay, let's test. Let's test what happens Yeah, I want to run this anyway. Let's go. So, see, I'm actually going to type into input. That's how it works on Google Colab. So, okay, let's say length is 3. Let's test a sample. That's a sample. 3, and then 4. Aha, okay, this is what causes the crash. Let's read the error. Can't multiply sequence by non-int of type strstr. Okay, so in Python, input, it reads the line. So this is actually a string. What we want to convert it to a number so we can perform arithmetic on it. So I'm going to cast it into an int. Cast, convert, whatever you want to call it. Note that we can convert using this int function because the constraints guaranteed that the length and width are integers. So, okay, this is safe. We can do that. We do this. Alright, now we'll actually test it. I type 3, type 4, get 12. Does that match the sample input? Yes, it does. Okay. And you know what? Just for sanity, let's do a couple more. Right? Doesn't hurt. 5, 10. This is 50. Yes, it is. Good. Okay. Next. 7, 8, 56. Okay. So now we're a bit more confident that our program should be correct, because we've seen it work in action. I'm going to copy this. I'm going to submit code and paste it in. Just gotta wait for this to load. Why is this taking long to load? We should speed this up in post. There you go. Yeah. Everything looks good to me. If we submit... come on. Come on. Come on. Yeah, yes. 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 Yeah, yes. Come on. Yeah, accepted. There we go. Nice. Okay, so with that out of the way, let's quickly go over some common errors made by beginners on CompProg platforms. Okay, first mistake. Hard coding the values of the input to match that of the sample input and output, right? Like, I've seen some people, they would just do this. Right, and you run this, and you get 12. But if we submit it... Wait, I want to submit here. Then we should expect to see... Oh, what is it? What is it? What's the verdict? Wrong answer on test 2, right? It passed test 1 because it was expecting to see 12, and it did see 12. But remember that the samples are only one test case, and there's still a lot of other hidden test cases, and presumably not every single rectangle has an area of 12. So just keep that in mind. This one would basically be the same as going print 12. And that's more clearly wrong. Okay, second mistake. You shouldn't add extra formatting or whatever when outputting the answer. What do I mean by that? So I've seen some people, they'll do this. The area of the rectangle is, and then they'll do that. And so if I type 3 and 4, the area of the rectangle is 12. Right? And that seems correct. And, you know, the logic is all there because I've seen this mistake happen because this is usually how people code for the first time in classes and stuff. But the problem is, remember, the judge isn't a human. In order to test things to do the judging automatically, the judge is a computer, and the computer needs the output format to be exact. Because all the computer sees is that 12 was the expected output, and you outputted the area of the rectangle is 12. I'm saying that in quotation marks. And, you know, they don't match. So your program gets wrong answer. What else? You could also put here, for instance, in the input, like, please input the length. Please input the width. And then I'll remove this for now. I've already made that point. Okay, please input the length, 3. Please input the width, 4. Okay, it's 12. So, will this pass? What do you think? So if I submit... then I get wrong answer. Well, it's not as clear when it's interactive like this, but let's try to read it with like an input and an output file. I can go to custom invocation here. Custom invocation is, it's an existing thing. You don't want to see that. This is basically a chance for you to test your code specifically on Codeforces environment. And as you can see here, we have a separate input and output file. And if I do that, what happens is, yep, this also gets printed out in the prompt. It's also part of the output. And it makes the output not 12. And because your output's not 12, you get a wrong answer. So, I mean, the point I want to make is just you don't need to do this stuff. This is for humans. We're not dealing with humans. It's all computers here. Final point I want to make, and this is a bit more nuanced, is that when we say exact output format, we do mean exact. And for instance, here in the rectangle, it asked for an integer output. And what that means is your answer shouldn't contain a decimal point. This is most likely to happen in Python 3, where using single/slash division always results in a floating point result. Right, if I remove this, if I print 6/2, you'll see the answer is 3.0. So it's not an integer anymore. Right, if it wanted 3, it should say 3, not 3.0. So this would actually get incorrect. I'm going to prove it. I'm going to replace this print. I'm going to just use some formatting here. So what I want to do is make this f string, format this way. And then I'll say 215 decimal places. So watch, I'm going to run this. I should have removed this. Hold on. Okay. I am going to run this. I input 3. I input 4. The answer is 12.00000. And that's correct. But it's unfortunately not in the correct format. The format was supposed to be just 12. So if I submit, I get a big, fat... What is it? WA, right? WA, WA for wrong answer. So, yeah, so technically in computer science, 2 is an integer, 2.0 is a floating point number. They're stored differently, so they're processed differently. If you want to do integer division in Python, the best way is to just use this double slash for integer division. If you do it this way, then your output will stay an integer. As you can see here, it's still 3. So anyway, it doesn't really matter. Just remember that if the output should be an integer, don't print out decimal points. Before we end, let's look at the one last problem. I wrote a poem here. So you can read it. I'm not going to read it. Basically, a firefly first flashed its light exactly X seconds after you first noticed it. And from that point on, it flashed its light every Y seconds. So at a regular pace. If X equals 5 and Y equals 3, so we start at 5 and then every 3 from there. So the firefly flashed its light at times 5, 8, 11, 14, 17, and so on. So here's the problem. Given X and Y and some positive integer n, find the time when the firefly would flash its light for the nth time. Okay, let's look at the input. 3 lines, X, Y, and N. Okay, makes sense. X and Y go from 1 to 1,000. N goes up to 10 to the 15. Interesting. Okay, then the output. Okay, just output the integer. Let's check the samples. 5, 3, 4. The answer is 14. Does that make sense? Well, x equals 5, y equals 3 is this case. Then we look at the first, second, third, fourth. It's 14. Okay. Makes sense. If we start at 1 and then count every 2, get up to the 10th, we get 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay, yeah, so this makes sense. We understand the problem. We should be good. Let's solve it. Okay, so what do I want to do? What we basically want to solve, right, is that it's x for the first time, and then it's plus y, plus y, plus y, and so on, plus y, and then we do omega naught plus y, n minus 1 times, right? We're doing this n times, but the first one should be x, the rest should be y. Okay, so I'll read the input. Each comes in its own line, so I can do this. I'll just copy paste that. And place. So let's just simulate that behavior with a loop, if you know how to do that. So the answer is equal to x for I in range n minus 1. I will ans plus equals y. And then let's print the answer. Okay, does this work? We have to test it. Remember to test it. So 5. No, didn't want to type that there. 5 and 3 and 4. 14. Yes, it was supposed to be 14. Okay, good. The other one is 1 and 2 and 10. Yes, the answer is 19. Okay, this is correct. We know this is correct. Yeah. Okay, good. Let me submit. I will change. Okay, it's already C, Python. Alright, let's go. And okay. Show me accepted. Show me accepted. Time limit exceeded on test 3. Okay. So last thing I want to discuss for this video, how do we deal with time limits? So basically it goes like this. The running time of your program is directly related to how much stuff it does. And by stuff, I don't necessarily mean the length of code. Right? It's the whole point of programming is that things like for loops can perform a lot of repetitive work with just a little bit of code. No, I mean, try to count how many basic operations is our program performing. A basic operation is just something like making a variable or adding two numbers, checking an if statement, stuff like that. When you're shopping for a computer and it says, 2.4 gigahertz processor speed, this is what it's referring to. Giga, meaning 10 to the 9, implies that a modern computer can typically do about 1 billion operations per second. Right? But those are low-level hardware operations like access this bit of memory, or write to this bit of memory. There's still a conversion from our high-level programming language to those low-level hardware operations. For Python, we'll assume that a computer can do at most 10 to the 7 basic operations in a single second. Remember that magic number. Let me type it down. A computer can do approx 10 to the 7 basic Python operations per second. So here's the general plan of attack. We'll try to estimate the number of basic operations that our program is performing. Right? Just estimate it, doesn't have to be precise. Then divide that estimated number by 10 to the 7. And that should give you a very rough estimate for the number of seconds your program will take to complete. So we emphasize that this estimate is very rough and is only intended to tell us the general order of magnitude of the operation count. But general order of magnitude is actually sufficient. Right? Let's look back at our program. How much stuff is it doing? How many basic operations is it doing? As I hinted at earlier, we should be looking at this for loop. Right? This for loop runs n minus 1 times. So the number of basic operations we're performing is proportional to n. Okay, so if we're gonna do about n operations, how big can n be? Okay, well, that's what the constraints are for. The constraints say n can be up to 10 to the 15. Okay, so remember the plan. So we can do 10 to the 7 basic operations per second. We're gonna do about n operations, and n is 10 to the 15. So if I want to calculate the number of seconds this is going to take, 10 to the 15 divided by 10 to the 7. Well, I mean, I didn't need a computer to do this for me. It's 10 to the 8. And 10 to the 8 seconds is approximately 3 years. So, yeah, I said this wasn't going to be super fine detailed, but it doesn't have to be. 3 years is clearly way longer than the 1 second time limit that we had. So, yeah, that's not going to work. To solve this within the time limit, we have to be a bit smarter, and as you might have guessed, it'll involve getting rid of this loop somehow. And with a bit of math, right, I mean, we can see that we want to do this y plus y plus y plus y n minus 1 times. But do you remember that doing that repeated addition is the same as multiplication? So if we do this, let's try that. Let's say the answer is equal to x plus y times n minus 1. Print out the answer. Good habit to always just test anyway. 5, 3, 4. Still 14. And 1, 2, 10. Still 19. Okay. And let's submit. Yep, yeah, accepted. There you go. So, not all problems are going to have magic math formulas that solve them, but, that's okay. Doesn't have to be a magic formula. Remember, you can afford to perform several million operations, and that's a lot. Computers can do a serious amount of work, but just remember, they aren't magic. Now, what we just had here was a very quick and dirty explanation. We glossed over a lot of detail and nuance. If you're interested in a more thorough treatment, then you can Google the terms algorithm analysis, or big O notation, or computational complexity. We've also left some links in the description to material that we recommend. Okay, that concludes our first video, which went over the basic format of NOI.ph, and also talked about time limits a little bit. So this format in the problem set is also the same as the ones you would see in the problem set archives of Codeforces or AtCoder or other useful resources for those who want to train seriously. So thank you for watching, and we hope to see you every Saturday. Vis Abacoda.